Greetings. This is Unit 5, Module 2, Session 4. The name of this home connection is Symmetry. Put your name and number at the top, please. Figures A through C, so these are our figures here, they show only half of the designs on the left side of their lines of symmetry. Complete each design on the right side of the line of symmetry. So if I were to take like a card of some sort, I could cover up that line of symmetry. You can see the example there, that they translated it across the line of symmetry so that it would fold perfectly in half and you'd have the exact same shape. Okay? So when I'm looking at a line of symmetry, one of the things that I'm going to do is probably count squares if you're on a grid, because that would be very helpful. Because if you have a point on it, and then you have other points that are in precise locations, well then I can go, okay, from the center it looks like it's over 1, 2, 3, up 1, 2, and then so you'd go over 3, 1, 2, 3, and then up 2, and then it would match perfectly. Same for this point down here, down 2, out 2, and then you do it on the other side, down 2, out 2, and then when you take your ruler and connect all the dots, you have that perfect mirror image. You have that symmetry. Okay? So if I look at this diamond, I'm going to do the exact thing that I just demonstrated. So there's our center point, so life is good. We're going to leave that there. But if I want this point, and this point to be present, well then I need to count how far up and over to go. 1, 2, 3 up, 1, 2, 3 over. So I go 1, 2, 3 up, 1, 2, 3 over, and I'm going to draw my point. Okay? If I want to do this one, it's 1, 2, 3, 4, 5, 6 over. 1, 2, 3, 4, 5, 6 over. And then this one down here, it's 1, 2, 3 down, 1, 2, 3 out. So I do it again. 1, 2, 3 down, 1, 2, 3 out. And then I draw my point. Then when I take my ruler and connect all of those dots, sorry if I cover this up at all, I should have just a gorgeous symmetrical image that I could technically fold in half, and then it would work perfect. They would fold over perfectly. Okay? So, count from your center line to find your image. Okay? I am going to let you do C on your own, because I think you can do that. There's your center point, and it looks like there's 1, 2, 3 other vertexes that you can put on the opposite side and connect the dots. This one here, though, I just want to discuss. I'm going to let you do it on your own. But if you're going to find out where this point is, then you have to decide. Are you going to count from here, here, or here? Because your answer is going to be different depending on what you look at. If you count from here, you go 1, 2, 3, 4 up, 1, 2, 3 in. But if you did the same thing from here, 1, 2, 3 up, 1, 2, 3, right, it's not going to work out, okay? So I highly suggest that you pick a point, and maybe it is just right in the middle, and then you do all of your calculations for all of the other points, okay? Because you're going to need to be very consistent. So if you start from here to find all of them, the other 3, it's totally fine, okay? Or if you use this or this, that's fine, but you can't switch, okay? So pick a point and then do it. So 1, 2, 3 up, 1, 2, 3 in, 1, 2, 3 down, 1, 2, 3 in, and then you can just go 1, 2, 3, 4, 5, 6 out, okay? But I'm going to let you do that one on your own. It says, what did you do to make sure that the other half of each design you drew was accurate? Okay, what do we do? For what I suggested is that count squares, use a ruler, okay, find points. Those are all things that we did. because it's really hard to draw some of these lines here if you don't know where it's going, because there's a point there and there's a point there that line up perfectly on the grid, but all of the line in between really doesn't hit anything that's easy to see. So if you kind of had to freehand it, gosh, that would be really difficult. Fortunately, if you know where two of the points are, you could just use a ruler to have that perfect line. Okay? So if you had any other strategies, you can list them here. If not, we can look at the next page. Preston says that when a figure has a line of symmetry, the halves of both sides are congruent, which means exactly the same size and shape. Do you agree or disagree with him? So when a figure has a line of symmetry, the halves on both sides are congruent. They're exactly the same size and shape. Here's my line of symmetry. Is this the exact same size? It is. Is it the exact same shape? Oh, well, actually, it's a mirror image of the exact same shape. This one, technically we could say that's true for, but then we also have a shape with equal sides. So it doesn't really matter if it's a mirror image, okay? So I would say that we sort of agree with that. But for me, it would be, the shape part is kind of difficult to handle. As long as you mention that it's a mirror image of the exact same shape, then yes, I would agree. But is it the exact same shape? Technically, no, right? And you can write this in, and you can draw pictures if you want to. But for sure, yeah, both halves are the exact same size. Yep, that's true. And this is going to just be dependent on how you understand mirror images, okay? Because if I take let's say, oh gosh, I don't know if I have any grid paper nearby to be able to show you. Oh, of course I do. Right there. Hello. So if I were to take, let's say, this grid paper, and I create a line of symmetry, okay, and then I do something that's kind of fun in size. Here's maybe my center point, and I'll go 1, 2, 3, 4, 5, 6, 1 over, okay. I'm going to make sure it matches as I do it, okay? And then maybe I come over, let's see, 1, 2, 3, 4, 5, 1, 2, 3. Oh, 1, 2, 3, 4, 5, 1, 2, 3. And then maybe go 1, 2, 3, 4, 1. And I'm going to make something a little unusual, just so that this stands out to you. Okay, so here I have my two images, and yeah, they are the same size. But if I were to cut this out, and I were to cut this out, they would not overlap, right? I could fold them, and then they would match. But this has its high point on the right side. See how it kind of looks like there's a triangle here? Like it looks like a square with a triangle on top. But this has its point on the left side. So are they the exact same shape? To a certain degree, yeah, especially if I was allowed to manipulate them, but they wouldn't lay on top of each other perfectly. They would fold over perfectly. And that's the distinction that I'm trying to make. Okay, let's move on to number 4. I feel like I talked too much about that one. Tasha says that this shape has 4 lines of symmetry. Do you agree or disagree with her? Explain your answer. Be sure to draw in any lines of symmetry you can find. So hint, you can trace the figure, cut it out, and fold it before you make your decision. So, what if I just did that right now? I had one that was that I used a die cut for, but I have misplaced it, which is kind of a bummer. So I have an extra rhombus that I'm going to cut out. And we're going to see how many lines of symmetry we can find. We know that squares have 4 lines of symmetry. Side to side, top to bottom, corner to corner, and corner to corner. But here is my rhombus. If I try maybe a down the middle approach, ooh, gosh, that does not fold over. So I don't have a top to bottom line of symmetry. Let me try side to side. So if I fold it in half like this and try to line up the corners, ooh, gosh, that also does not fold over. You can see how those edges here don't match. So that doesn't work. Maybe corner to corner. So let me see if I can fold this over. Oh, that's not working. Just trying to get these to line up at all. Gosh, no, I can't even get the short corners to work. I end up with almost a butterfly shape. So when I look at this rhombus here and I try to fold it over to find a line of symmetry, I'm not finding any at all. So do I agree with Tasha? No, I disagree. It has no lines. And finally, find a picture in the newspaper, in a magazine, or on the computer that has exactly 2 lines of symmetry. Explain how you would convince someone that it has exactly 2 lines of symmetry. I could take a random thing from my classroom, just as an experiment. In this case, I have the famous Batman logo. And if I were to fold it in half, if I drew a line down the middle and I folded it in half, it would be symmetrical, okay? But if I drew a line across the middle and tried to fold it, it would not. It's close, but not quite. So I have one image in here that does not quite work. So I would have to go back to the drawing board and find another. So as you're looking around, you could even sketch it if it's something that you can't like print off. If it's something you find online, you could just sketch it down here and then try to find 2 lines of symmetry on it. That would be excellent. Explore. Some shapes are pretty unique, like some stars work. Obviously, squares and rectangles, things like that, have great lines of symmetry. But there are also some unusual shapes that do as well. Okay, so enjoy this one, have some fun with it, get creative, and if you have questions, as usual, ask someone that you trust. Teachers love to help with math. Remember that. Check you later.